Hello students, welcome once again. Today's video is very important for the students of class 11 and the standard 10 ICSE board. In today's video, we will learn about molecular formula, that is how to determine molecular formula. But before that, we need to know what molecular formula is. So let's start the video, and I would request that before you watch the video, you take pen and a notebook and keep on writing with me, and as well you please watch this video from start to the end without skipping. So let's start. So what is a molecular formula? Or rather, I would give you, instead of definition, what does molecular formula tells us about. In your standard, in your level, question will never be asked what is a molecular formula, but it is better to know what does it give us. It tells us about the actual number of atoms of various elements present in the molecule of a compound. Okay, now suppose say glucose. Its molecular formula is C6H12O6. So this is the molecular formula. It is telling us that glucose has 6 atoms of carbon, 12 atoms of hydrogen and 6 atoms of oxygen. So this is molecular formula. Now in order to determine this molecular formula, we have to know about another type of formula which is known as empirical formula. So the next topic you must know is what is an empirical formula. Well, okay students, this empirical formula, it tells us about the whole number ratio of various elements present in the molecule of a compound. For example, this glucose, empirical, I am shorting right, empirical formula of glucose is CH2O. That means empirical formula tells us that there are the ratio of carbon, hydrogen and oxygen is 1:2:1. So empirical formula just gives us the ratio that is in whole number ratio of the various elements present in the molecule of a compound. Now the question arises is, if we want to calculate molecular formula, then we need to know empirical formula. Then there must be some relation between molecular formula and empirical formula. Then what is that relation? Now we will learn about that. Here I must rectify the spelling. It is empirical. Please remember PI. So what is the relation between molecular formula and empirical formula? See here students, molecular formula also has a relation integral. It is whole number multiple of empirical formula. Relation between, I am writing in short, D/W, that is between molecular formula and empirical formula, EF. Okay, the relation states that molecular formula molecular formula is whole number multiple of empirical formula. This is the relation. That means molecular formula is equal to n. If we signify this whole number by n, is n into empirical formula. Okay, so we can find out n. N is equal to what? Molecular formula divided by empirical formula. So this is the relation, and from this we can derive another relation. Now we are also required to find out what is molecular mass. You know, molecular mass is what? Sum of atomic masses of various elements present in the molecular formula. Similarly, empirical formula mass we can write here is equal to sum of atomic masses of various elements present in the empirical formula mass. So this is, you must know. Now suppose we have, say, C6H12O6. So its molecular formula mass is what? Molecular mass is what? 6 into 12 plus 1 into 12 plus 6 into 16. So 72 plus 12, so 96. So this is 110, carry 1, 9, 1, 10, 17, 180. So this is 180U molecular formula. Now if you are asked to find out empirical formula, that is CH2O. So here empirical formula would be, empirical formula mass is what? We can write it here, or molecular mass also, 12 plus 2 plus 16. So that is 12 plus 2, 14 plus 16, 30. So in this way you calculate empirical formula mass or molecular mass. So you must be knowing about that, but still we need to revise. So molecular formula is the whole number multiple of the empirical formula, and so we can write molecular formula is equal to n into empirical formula, or n is equal to molecular formula by empirical formula. Now all these things will be more apparent, more clear to you once we solve numerical based on this concept. So let's solve some numerical. So I have a question for you. Through this question you will be able to understand how to calculate empirical formula. So see here, the question is, a substance on analysis gave the following percentage composition: sodium 43.4%, carbon 11.3%, oxygen 45.3%. So calculate the empirical formula. Now when calculating this kind of question, what you have to do, you make a box like this. First column should be the name of the element, then percentage composition, then after that the atomic mass, then you should have relative number of moles, then this should be a little bit bigger, simplest whole number ratio. So this is the box. So what are the elements? There are 1, 2, 3 elements, okay, that is sodium, then carbon, and then oxygen. So let's try to solve. The percentage is 43.4, carbon 11.3, and oxygen 45.3. Atomic mass of sodium 23, carbon 12, and oxygen 16. Now please remember, while finding relative number of moles, you divide percentage by, this is equal to percentage divided by atomic mass. So 43.4 divided by 23, then 11.3 divided by 12, then 45.3 divided by 16. So what's the answer? Now when you will divide 43.4 by 23, we get 1.88 as the answer. When we divide 11.3 by 12, we get 0.94. You can check yourself. And when we divide 45.3 by 16, we get 2.83. Okay. Now in order to, first we should make one more column. First simple ratio, then simplest whole number ratio. Okay, one thing. So first step, after making this table, you divide them. Now to find the simple ratio, what you have to check? You have to check out of 1.88, 0.94 and 2.83, which is the smallest. Find the smallest relative number of mole and divide. So here we are seeing this is the smallest. Okay, so we have to divide all these numbers by this 1.88 divided by 0.94, then 0.94 divided by 0.94, and 2.83 divided by 0.94. So obviously this will come as 1. Now when we divide 1.88 by 0.94, it comes out to be 2. And when we divide 2.83 by 0.94, this comes out to be 3. Now sometimes what happens, instead of getting 2, you can get 2.4 or 2.5. So that's why this column is necessary. You have to change that fractional number by multiplying with certain number and that number with which we will multiply to change that fractional number into simple whole number ratio, you have to multiply all other numbers by the same number. But here we are seeing that these numbers itself are in simple whole number ratio, so no need of changing them or multiplying by any other number. So the ratio becomes 2, 1 and 3. So that means the empirical formula is Na. There are 2 atoms of Na, 1 atom of carbon and 3 atom of oxygen. So the formula is Na2CO3. So in this way we can find empirical formula. Again I would revise. First you make a table consisting of 1, 2, 3, 4, 5, 6 columns. Remember, 6 column. First column, name of element. Second column, the percentage given in the question. Atomic mass, it might be given, may not be given, you must know it. Third column, relative number of moles. How to find out? Divide percentage by atomic mass, and then simple ratio. While finding this, what we have to do? You check the relative number of moles. Here we are having 3. Out of these 3, you check which one is the smallest. We find that out of 1.88, 0.94 and 2.83, this is the smallest. So what we have to in the next step, we have to divide all 1, 2, 3, all these by 0.94. So when we divide them, we get the ratio, that is 2, 1, 3. Sometimes you may not be getting this simple ratio, you can get in fraction. In such case you have to multiply by some other number to change it into simplest whole number ratio, but that case does not come here. So here simple ratio and simplest whole number ratio both are the same. So finally we get the molecular formula, the empirical formula. We have to find the empirical formula, as Na means simple whole number ratio is giving us the number of atoms of Na. So that means there are 2 atoms of Na, 1 atom of carbon and 3 atoms of oxygen. So in this way we can find the empirical formula. You please note down, then we will solve another kind of question. So we have another type of question. The question reads, an organic compound on analysis gave the following data: carbon 57.82%, hydrogen 3.6% and rest is oxygen. Its vapor density is 2. Find its empirical and molecular formula. So here you are getting one question, that is its vapor density. Topic. This is a new term for you, vapor density. Anyways, we will make use of it here. Now first of all, you see here carbon is given as, carbon's percentage is given, hydrogen's is given, but oxygen is not given. How to find out? Just subtract them from 100, 57.82 plus 3.6. So this is 100 minus 57.82, 3.6 by 2. So that is 61.42. So on subtraction, what do we get? Percentage of oxygen as 38.58. Okay, so this is the percentage. Now we have to make 5 columns, 6 columns, you know, element, then percentage, atomic mass, relative number of moles, simple ratio, simplest whole number ratio. So we have here how many elements? We have here 3 elements. So let's make the box. I should not be in hurry. I made a the element is carbon, hydrogen and oxygen. Carbon's percentage given 57.82, hydrogen 3.6, oxygen we have calculated 38.58. Atomic mass, this is 12, this is 1, this is 16. Okay, so now the next, that is relative number of moles. What do? We divide percentage by the atomic mass, 3.6 by 1, 38.58 divided by 16, so this will come out as 3.6. now these two you have to divide. This comes out to be 4.818 and this one 2.4. now see, out of these three, this is the smallest, so that means we have to divide all these three numbers by this small number, 4.818 divided by 2.4, 3.6 divided by 2.4 and 2.4 divided by 2.4. This comes out to be 1. When we divide 3.6 by 2.4, it comes out to be 1.5 and this comes out to be 2. Okay. Now one problem has arisen. Just now in the last example I had told you, see, this is a fraction. We have to change this into whole number ratio. How do we do it? We have to multiply it with such a number that it changes to a whole number. If we multiply this with 2, then it becomes 1.5 into 2, it becomes 3. Now when we are multiplying a number by 2, you have to multiply the rest numbers also by 2. So 2 2s are 4, this is 3 and this is 2. I'll write it here, 1.5 into 2. Because it is a fraction, so we have to change this into a whole number. So 2 into 2 and this one is 1 to 2. So we are getting carbon, hydrogen, oxygen, 4, 3, 2. So the empirical formula we have calculated equal to what? We have C4H3O2. So this is the empirical formula we have calculated. First part we have calculated. Now we have to calculate the rest part. So for that I have to rub this. I am rubbing it. Now see, we have to calculate empirical formula mass from this empirical formula. So that is from here, 4 into 12 plus 3 into 1 plus 2 into 16. So this comes out to be 12 4s are 48 plus 3 plus 32. So on addition it comes out to be 83. 83. Now what is the molecular mass? Now see, molecular mass can be calculated from this vapor density. You are getting a new concept here. Molecular mass is equal to, please remember, N into vapor density, that is this is the formula. So here the molecular mass is 2 into 83, not n into 23, that is vapor density into empirical formula mass. So this is vapor density is what? 2, so 2 into 83, so that is 3 2s are 6, 8 2s are 16, 166. Now we required N, that is molecular mass divided by empirical formula mass. So this is equal to 166 divided by 83, so this comes out to be 2. So molecular formula is equal to what? N into empirical formula. So this is equal, N we have got 2 and empirical formula we have got C4H3O2. That means you have to multiply all these number by 2 here. So we get C8H6O4. So molecular formula of this compound comes out to be what? C8H6O4. So in this way we have calculated the molecular formula of the compound. Now you must remember this formula, that is, if you in your question vapor density is given, you multiply the empirical formula mass, that is this, with the vapor density, then you will get molecular mass. You divide molecular mass by the empirical formula mass, you get the relative number, the N value. Then there is a relation between empirical formula and molecular formula, and empirical formula is that you have to multiply empirical formula with N. We have already calculated empirical formula as C4H3O2. Here we have calculated. You just multiply this with 2, so we get the answer. So this is another kind of question which tells you how to find out the molecular formula. So I hope you have got very good 2 examples and you have grasped how to calculate molecular formula and empirical formula. So for better understanding, you can watch this video once again, and please like the video, share the video and subscribe my channel. So until the next video, it's Frank Guruji wishing you all the best.